Okay, this is extra practice on graphing linear equations. So sometimes you're given linear equations like this one, and it asks you to graph. Okay, so the first thing we want to do when we have a linear equation, okay, is to come up with a table of values, because we all know how to graph data from a table, right? But in this case, we don't have data on a table, we have it in an equation form. So we're just gonna translate this into a table form. All we're doing here is you're picking any value of x. You can go, what's y when x is 0? So when x is 0, and you just go to your equation and you're just plugging in y is equal to 3 times 0 plus 10. This gives us 0 plus 10, and y is equal to 10. So y equals 10 when x is 0. And you do another one. Let's say, what about when x is 2? So y is equal to 3, x is 2. So 3 times 2 plus 10, I get 6 plus 10, and that gives me 16. I have another point. So I have a point at 0 and 10. I have a point at 2 and 16. Let's do another one. Let's do when x is equal to 4. So y is equal to 3 times 4 plus 10. That gives us 12 plus 10 is equal to 22. So 4 and 22 are ordered pairs here. Okay. Now I have 3 points to work with: 0 and 10, 2 and 16, 4 and 22. What this tells me is that when x is equal to 0, y is equal to 10. When x is 2, y is 16. When x is 4, y is 22. Okay, now that I have points that I can graph, I just have to draw my graph. Okay, looking at my data, I don't have any negatives, right? So I'm just gonna put my axes close to the end like this. So I'm focusing on the positives. My x goes up by 2. So I'm gonna go 2, 4, 6, 8, 10 on my x-axis, and my y has a bigger number. So maybe I'll go up by 2s, but I won't skip every graph. So I'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Notice how the axis that I use for my x and my y, they don't have to be the same. Just because I skipped a space for my x doesn't mean I need to do that for my y. Okay, now my graph is set up. I just need to plot my points. Okay, so I need to go when x is 0, y is 10. So when x is at 0, y goes all the way to 10. I plot a point there. This point is 0 and 10. Okay, and then next one I have 2 and 16. So when x is 2, y is all the way to 16. Okay, and my last one I have 4 and 22. Okay, I have 4 on the x and 22 on the y, and those are the 3 points that I got on my table. Okay, but we need to remember that looking at this equation works for any value of x. This x can be anything. It was my choice to choose 0, 2, and 4, and that's why I have 0, 2, and 4 on my graph. Okay, but because this x can be anything, on here, I can connect this line and make it into a linear graph. And I'm gonna add an arrow on both sides because it will keep going, okay, no matter what value of x it is. Right, so that's it. I had to look at my equation, make a table of values, and then graph it over here. Okay, I'm gonna do the same for the other ones on this page. Same thing, I'm gonna go an x and y table. Okay, using this equation, I'm gonna figure out. This time I'm gonna do different numbers. I'm gonna see what y is equal to when x is 10. So y is equal to 2.5 times 10. That gives me 25 minus 1.3, 23.7. Okay, so y is 23.7. What about when x is equal to 20? Times 20 minus 1.3, that gives me 2.5 times 20 is 50 minus 1.3 gives me 48.7. So that is 48.7 right here. What about when it is at 30? Y is equal to 2.5 minus times 30 minus 1.3 gives me 73.7, so that's my other point here. Okay, so these points are a little bit trickier to graph because they're in decimals. Okay, but that's okay. Okay, we're not making it to the point 0.7. We can kind of estimate where that would be on the graph. Okay, again, I don't have any negatives, so I'm gonna draw my graph something like this. Okay, I go 0 in the middle where my origin is. My x goes up by 10, 20, and 30, so maybe I'll skip 1, 2, and go 10, 1, 2, and go 20, 1, 2, and 30. 2, and I'll go all the way to 40 on my x-axis. On my y-axis, I have to go all the way to 70. Okay, so maybe I'll go 10, skip 20, 30, 40, 50, 60, 70, and all the way to 80. All right, so now I'm graphing these 3 points on this graph. Okay, see how I got 3 points from this equation. Okay, so whenever you have an equation, you should end up with a linear graph. Okay, not just 1 point, a graph that represents this equation. Okay, so the first point I want to graph is 10 and 23.7. So I go where x is at 10, and 23.7 is going to be a little less than 25. So let's go right here. And then 20 and 48.7 is going to be a little less than 50. 30 and 73.7 is going to be a little less than 75, so I go right here. Okay, and then I connect the lines again, and that gives me a linear relation. And this whole thing, this line itself, represents this equation. Right? So although these numbers look a little tricky, but it's okay. We are just graphing it onto a graph using the scale that I want. Okay? See, I wouldn't have made my scales 1, 2, 3, 4, 5, 6, 7. I would have to draw all the way to 75 to fit this in, right? So it's up to you on how you draw your x and y scales. Right, sometimes we have a negative coefficient here. Okay, so let's see what happens. It's the same thing, right? Once you are used to making a table of values like that, okay, I'm going to show you. You don't always have to use it, okay? I'm going to show you what we can do. Okay, what you're going to do is, we're going to skip the step of drawing the table of values, and we're just going to go straight to drawing the graph. I'm just going to draw a graph right here. I'm just going to do 1, 2, 3, 4, 5, -1. Oh, I want to go down by 1. Okay, -1, -2, -3, -4, -5. That means I need to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then maybe some negative numbers here. So this will be -1. Okay, so I have my graph. Now I need to plot the points without doing the table of values. All that we were doing before was figuring out what y is when x is a certain value. Let's do the same thing here. Okay. We're gonna figure out what would y be when x is 1. So just plug it in your head. Okay, or you can just write it on the side if you want. Okay, so when x is 1, you go -2 times 1 plus 1.5. That gives me -2 plus 1.5. It's -0.5. So when x is 1, y is -0.5. So when x is 1, y is -0.5. It goes right here. I'll use a different color. When x is 1, y is -0.5. Okay, let's do when x is 2. When x is 2, okay, you go -2 times +2, because we're trying to figure out when x is 2, plus 1.5, -4 plus 1.5, -4 plus 1.5 gives us -2.5. So when x is 2, y is -2.5. So when x is 2, y goes to -2.5 like this. Okay. What about when x is 3? So we just go -2 times 3 plus 1.5. That gives us -6 plus 1.5 it's at negative 4.5. So I go, when x is 3, I go all the way down to y is equal to negative 4.5. Okay, so we are kind of doing the table of values, but we're skipping making the table. Okay, so if you like to keep yourself organized and do the table, that's fine. If you want to skip the table and just do the quick calculations, what is it when x is 1, 2, 3, or whatever number you choose on your scale. Okay, and you figure out those y points, and you need 3 or 4, and once you have that, you can just connect the lines like this. Okay, and that is your graph. Okay, one thing I want you to notice is, look what happens here. Okay, what I have is a positive coefficient in the first ones, positive 3, positive 2.5, and here I have a negative 2. Okay, you notice that this one actually goes downhill and these go uphill. Okay, what else do you notice? Do you see how this 10, the constant here, is where it crosses on the y-axis? Here it's supposed to be at 1.5 and it is approximately 1.5. So those are the patterns that I want you to see when you're graphing these equations. Okay, so for extra practice, try the other 3 on this page. Okay, if you have any questions about this, let me know.